Let's talk about errors in Go. We usually think of them as these simple little stop signs in our code. Something goes wrong, an error pops up, end of story. But what if they could be more? Today, we're going to pull back the curtain and see how Go errors can go from being basic failure flags to these powerful, data-rich messengers that tell you the entire story of what went wrong.
I mean, think about it. The last time you saw an error in your app, what did it say? Probably something kind of generic, right? Like invalid input or maybe record not found. And sure, that tells you something failed. But is that really enough? What if you need to know why? What if the story behind the failure is actually the most important part? This is the exact headache a developer, let's call him Ethan, is dealing with. He's working on a simple registration form. A generic error like error invalid input just doesn't cut it. He needs to be able to tell the front end, hey, the email field is the problem and it's because it's missing the @ symbol. A simple Sentinel error variable, well, it just can't carry that much information. It's not designed for it.
And that really gets to the heart of the problem here. Sentinel errors, these predefined error variables, they're great for checking simple states. But they just hit a wall when your app needs to communicate more complex details about what went wrong, especially for something like form validation. So what does Ethan try first? Well, his first instinct is to change his function signature to return the details, the field and the reason, separately, right alongside the error itself. Now, this is a classic code smell in Go. It completely breaks convention, and frankly, it just creates a mess. Just imagine this error needs to bubble up through 3 or 4 other functions to get to the user. Are you going to rewrite every single one of those functions to pass along these extra return values? No way. It's a total nightmare to maintain.
The real solution, the elegant one, lies in a fundamental truth about Go that a lot of us, myself included, kind of miss at first. We get used to thinking of an error as just a string, a piece of text. But that's not the whole picture. The reality is that a Go error is something way more flexible and way more powerful.
And here it is. This is the big aha moment. In Go, the error type is simply an interface with just one method, error, which returns a string. That's it. This means any data structure you can dream up can officially become a Go error, as long as you give it that one method. This ridiculously simple rule is the key that unlocks everything.
Okay, so if any type can be an error, well, let's build one. Let's build an error that carries the exact data we need. We're going to move from theory into practice now and actually construct our very own custom data-rich error. Let's see how it's done. So the first thing we do is design a custom little container for our error details. Think of it like building a special envelope. Instead of just scribbling a message on a piece of paper, we're creating a struct that has dedicated slots for the field that failed and the reason it failed. This is exactly what Ethan needed, a neat, tidy way to package email and must be a valid address together. And turning this struct into a real, official Go error is incredibly easy. It's just a couple of steps. 1, you define your struct to hold all your rich data. 2, you add that required error method, which just tells Go how to print your error as a simple string if it needs to. And boom, that's it. Step 3 is done. Your custom struct is now a first-class, 100% legitimate Go error. Okay, awesome. So we've successfully packaged up all our specific details, the field, the reason, inside our custom error. We've mailed the letter. But now for the next big question. How do we get that data back out when we catch the error somewhere else, like in our HTTP handler? How do we open the envelope? The tool for this job is a fantastic built-in function called errors.as. Think of it like a special key. It's designed to inspect an error, no matter how it's wrapped or passed around, and check if it matches the type you're looking for. You just give it the error you caught and an empty variable of your custom error type. If it finds a match, it unlocks it and neatly unpacks all that rich data, like valerror.field and valerror.reason, so you can use it to build that perfect JSON response. Now, to really understand why errors.as is such a game changer, we need to talk about wrapped errors. And the best way to picture this is with those Russian matryoshka nesting dolls. In Go, it's super common to wrap one error inside another. So your validation error might be tucked inside a database error, which itself is inside a request handler error. And this right here shows exactly why errors.as is the modern way to go. A simple, old-school type assertion, well, it's like only being able to look at the biggest, outermost doll. If your custom error is nested a few layers deep, the type assertion just fails. It can't see it. But errors.as is smarter.
It methodically opens every single doll in the chain until it finds the one it's looking for. It's robust, it's clean, and it's built for how modern Go applications actually work.
So all of this brings us to a really simple, practical guideline you can use to decide which error strategy to use in your own code. Let's call it the architect's golden rule.
Here's the rule, laid out plain and simple. When your goal is just to check an error's identity, you're just trying to answer the question, what happened? Like, was the file not found? That's when you use a Sentinel error with errors.is. But when your goal is to extract data from the error, when you need to answer what are the details, like which field failed and why, that's the time to build a custom struct and use errors.as to get that data out.
Once you start thinking this way, the whole concept of Go's error interface just transforms. It stops being this frustrating limitation and becomes one of the language's most powerful features. Your error is now like a carrier pigeon. It can reliably deliver any payload you attach to it: validation details, HTTP status codes, maybe even hints about whether an operation is safe to retry, all the way up your call stack, safely and type-checked.
So the next time you're writing a function, don't just think about if it might fail. Think about what that failure needs to say. Your errors can now carry any payload you can imagine. The only question left is, what will you teach them to say?